3E. First, number 10, it says, the question states, the agency suffered a real cut in its annual budget. So there's a cut in the budget, but it had a higher dollar amount given to them. So is it possible to have a higher amount of dollars given to them and still get a real cut? And I guess the emphasis should be on the word real. In general, you would say no. But it's possible that you are given more dollars. Say you were given $100, and then the next year you were giving $110. And it looks like, no, that's not a cut, that's an increase, and that's a real higher dollar amount. But if the value of a dollar dropped so that it would cost to buy the same thing that cost $100 now costs $120, then it looks like you've got more dollars, but you can't buy as much, and so that could be called a cut, even though you got more dollars. So in an obscure sort of way, it is possible to have a real cut and still get a higher amount of dollars. But otherwise, in general, no. If you got less money coming to you, you've got a real cut and you don't have as much. So those are kind of the ways to look at number 10. All right, now let's look at number 13. We talked a little bit about this in class. It says, in Nebraska, this is 8th grade math test scores. In Nebraska, the white students got 281 as an average score, and the non-white got a 250 average score, but the overall average was 277. Now in New Jersey, the white's average score was 283, the non-white 252, with an overall average of 272. And the first question it asks on this one is, which state had the higher test scores in both categories? And that would have been, in this category, New Jersey was higher. In this category, New Jersey was higher. So New Jersey was higher in both of the white and non-white categories. And then the second, and then it says, which state had the higher overall? And the higher overall was Nebraska. So the question is, how can Nebraska have a higher overall average than New Jersey, and yet New Jersey has, in each category, a higher average than Nebraska? So in each category, New Jersey's higher, but overall, Nebraska's higher. How can that be? But they just asked for these answers at this point. So part B is asking this question: why can this be higher? Well, and this is a concept of weighted averages. Weighted as in WEIGHTED. And it's just like I mentioned to you in the drive from Clelm to Ellensburg. If you went 30 miles an hour and then 60 miles an hour to Vantage, and they're both at the same distance, it seems like they should be the average of these two. But you spent twice as long going 30 as you did 60, so your average is closer to 30 than to 60. Here, it must mean that in Nebraska, more students are white than are non-white, and so the average is closer to the 281. And in New Jersey, same thing, more white than non-white, so the average is closer to the 283. However, Nebraska probably has a higher percentage of whites, and so this brings this average even closer to the 281 than the overall average for New Jersey, which would be not as close to the 283, and so therefore it's slightly lower than the Nebraska one. So that's how it can be. And then they said verify the table using 87% and 13%. So let's just say that there was 1,000 students in each. Okay. So if there was 1,000 students and 87% of them got 281, so we would have, or let's just do 100, that would be easier. Then 87% of them would be 87 students, white, that got a 281 average. So we got 281 for 87 students, so times 87. Then we have 13 students, so that would be the rest of them. Out of 100, 87 are white, 13 are non-white, so 13 students. I got a 250. 250 times 13, which means then we have, we work that out. So 87 times 281 plus 250 times 13. That's the total for score of all the scores of all the students. And then we divide it by the 100 students, and we get an average of 277 for all 100 students. Now we do the other one. So 283 times 66 students plus 252 students, or an average of 252 for 34 students. And we get an average for all these. So we got the total divided by, we're dividing the total by 100 because we had 100 students all. And this would be 100 students total. And so we have 283 times 66. If that's the average, then you can think of 66 students getting an average score of 283 plus 34, the other 34%, getting an average of 252. And then we take and divide that by 100. And their average is 272.46. And that's how they got the numbers up here, 277 and 272. Okay? And so we verified the table and all the values. Now it says verify the overall. Well, we just verified the overall. And let's see, maybe I'm not reading this right here. Let me make sure I'm answering the question correctly. Now consider the table gives the actual percentage of whites and non-whites in each state. So that was this table down here that gave us the actual percentages. Use these percentages to verify the overall average for Nebraska. So we did that. That's C. Now use these to verify New Jersey. So that was D. So verified New Jersey and verify Nebraska. So I did C and D. And so now it says explain the apparent inconsistency. And the inconsistency they're referring to is Nebraska was lower and lower, but got a higher overall. New Jersey had higher, but had a lower overall. And the inconsistency is that New Jersey had more non-white students, so their average was closer to this one. You can see here 34 at the lower and 66 at the higher, whereas Nebraska was 87 at the higher and only 13 at the lower. And so because the categories are not balanced equally, that tends to throw the overall average off. And that's what they wanted you to understand on number 13. Let's go to number 14. Polygraph Test. And I'm going to fill out the table because that's basically what they want you to understand how they got their stuff. So they said there's 2,000 employees. So I'm going to put 2,000 down here for the total. And it said 1% use drugs. So taking out the calculator and going 0.01 times 2,000, and that says there's 20 that actually use drugs. So if you take 20 from 2,000, you get 1,980 that do not use drugs. Okay? Now we look at the accuracy of the test. And it's 85% accurate. So these 20 use drugs. So if the test is 85% accurate, then 0.85 times 20 should tell us how many it gets right. Well, if everybody says we don't use drugs, then this 17, all these users are not saying they don't use drugs, and 17 of them actually do, according to this test here, then it'll show the 17 as liars, and it will show the rest of them, the 3 of the rest of the 20, it comes out saying that they're being says they're saying they aren't users, and it won't catch them as being users, so it misrepresents those 3. Okay, and same for here, except the rows of the boxes are reversed. 0.85, 85% are going to get diagnosed correctly. So 85 times the 1980 is 1683. Now, they're all saying they don't use. And it's going to get 85% of these correct. So 85% of these, and they're all saying they don't use, and it's going to agree with 85% of them. So that's the 1683 that are saying they don't use, and this is saying the test will also say they don't use. It gets 85% of them right, and it gets 15% wrong. So that would be 0.15 times the 1980, which is the 297 that it says, yeah, they're non-users. Of the non-users, it says 297 are lying about them saying they're non-users. But that's incorrect. They are non-users, but this predicts that 297 are going to be testing as liars when they're not really by the polygraph test. So the total number that are going to get labeled as liars when they say they're non-users, we're going to be the 297 plus 17 which is 304, 314. The test people doing the research on this are going to say, oh, there's 314 people that are lying. Well, that's what the test will say, but that's not the truth of the matter. And there's actually, because there were 20 users, there's only 20 liars. This is saying there's 314 liars. And it's going to say that there's 1,686 people that are being truthful according to the test, but there's way more that are actually being truthful. This many are being truthful, saying they are non-users, and they really are non-users. And there's only 20 that are not being truthful. So it underestimates that. So now let's see if I've answered the questions here. Question 1 was, question A, verify the table below. So I just generated the whole table, so that's how it's done. Okay, and then B, how many employees are accused of lying? 314 are accused of lying. Of these, how many are actually lying? That would be the user saying they are not users. That's 17 of the 314 are not lying. What are actually lying? 17 of the 314 that the test says are lying, only 17 are really lying. And what percentage of those accused of lying are falsely accused? So the falsely accused are these 297 out of the 314, which is 94.6%. Of the ones accused of lying by the test, the lie detector, almost 95% of them are falsely accused, wrongly accused of lying. These guys said they were non-users, and they really were non-users. So that's a huge percentage of the ones that accuses of lying, not really lying. And that's part B. And then part C says, how many employees were found to be truthful? Truthful, 1,686. Of those, how many were actually truthful? Of these that were actually truthful, these guys said they were non-users, but they were. So the ones that were really truthful of all of them was 1,683. So of the ones claiming to be truthful, 1,683 divided by 1,686, 99.8, virtually 100% of them. That's a good number. Of the ones that it comes out to being saying truthful, almost 100% of them are being truthful. There's only 3 that weren't. Only a 0.2% that weren't being truthful. Okay? And that was part C. That's all of the polygraph one. Okay, the HIV one. Okay, I did do these in class, but yes, several people said they were having trouble. So I kind of wrote in the numbers here, but let's see if we can get them. So the first table is the at-risk population, I believe. Or is it not at risk? Let's see here. At risk. And that's a 4. At risk. So there's 5,000 people that are because of their behaviors, are more likely to get HIV test have HIV. So, of the 5,000, that's a total. They didn't leave this box for you out in this, but I put it on this table. And then we're doing of that 10% of the at-risk really do have HIV. So if we find 10% times 5,000 is 500 are actually have AIDS that are infected, 500. And that would mean 4,500 are not infected. Okay? And something's wrong here. What is going on here? Oh, let me read the borders. This test positive, test negative, and are not infected. Oop, I got these backwards. Infected and not infected. I got those backwards. Okay, so this should be the 4,500 that are not infected, and this should be the 500 there. That's what's wrong. Okay, now the test is 95% accurate. So if it really is 10% are of the at-risk have HIV, then we've got the 10% that are infected and 90% that are not infected. 90% of this and 10%. Of those, the test gets 95% correct. So if they have HIV, 500, they should test positive. So 95% of the 500 should be there. Let's see if that 475 is correct. 0.95 times 500. 475. The rest would be over here, or 95% from 100% is 0.05 times 500 is 25. Or you can take 500 minus 475 and you get 25, or 25 from 500 is 475. So that's where these numbers came from. Now, if it's still 95% accurate on this, these are not infected, so they should test negative. So 95% of these should go here. They don't have it and they test negative. That's 95% correct. So 0.95 times 4,500. And that's the 4,275. And subtracting that from the 4,500, and we get 225. Making the total here of 6,700. And the total here of 4,300. Making the 5,000 total. So there's that table, and first part we're supposed to do is part A, verify the incidental rates for the at-risk, which we've done. Now, and also for the non-infected. And so they said there was 20,000 total here. So let's just see if we can keep this straight. Okay. 0.3% of the 20,000. So we take the calculator and go 3% would be 0.03, but 0.3 would be 0.003. That's 0.3% of the 20,000 are actually infected. That's only 60 that are infected, which means the rest are not infected. 60 from 20,000 is 19,940, which should be what they had up there. Whoops, this should be, oh, they have the table backwards. I have it backwards again. This should be not infected. Infected. So this should be the 60 and 19,940. Let's see if I have that right. What? Yes, that's correct. Now they have over here infected 57 should be in here. How do they get that? Well, if the test is 95% correct, and this is a positive test, and they are infected, this would be the correct box, the number that are correct. And 95% of the 60 should be here. So we take 0.95 times 60, and it says 57 that should test positive, do test positive. And the rest of the 60, 3, should test positive, but they don't. Same idea down here, only now these are not infected, and so they should test negative by the test. And so 95% of that, 0.95 times the 19940, should test negative, and that would be 18,943. Actually, it should be all 19,940, but the test only gets 95% right, and that's the 95% of the ones that don't have a HIV should test there. And the rest should be over here, or the 5%, 0.05 times 19940, which is 997. So this is the 95% correct of this and the 5% incorrect on this. Not infected, but test that they are infected. So our totals here are 1,8,946, and the rest over here, see, 4 would make that 1,004, 1,014, I believe. And 1,4 would take this to 19,000 plus another 1,000, 20,000. Yes. Okay. So that's, I just verified the table by actually doing the table, but that's what you're supposed to check, is how that works. They didn't give you a spot to do the totals, but I'm showing how to work the totals. Okay? Now it says, in the at-risk group with HIV, so they do have it, that's these, the 500, what percent tests correctly? So that's the correctly tested are 475 divided by 500, which is 95%. Test always does 95% correct. Those tested, what percent? Let's see. Let me read the question. I only got parts of it here. Of those who test positive, that's those. What percentage actually have HIV? Oh, this is the tested positive. That's the 700. What percent actually have HIV that are infected? That's that. So that's 475 divided by the 700 that test positive. So 67, 68%. So of the ones that get a positive test result, only 68% of them, just a bit over 2/3 of them, really do have HIV. There's a whole lot that don't have it. Why the different answers? This one is based on the total number that are correctly diagnosed out of the ones that do have it. But when you've got so many that don't have it and 5% of them are tested incorrectly, that becomes a pretty good sized number compared to those that are tested correctly. And so we get a not so pretty answer for people getting testing positive but don't really have it. Okay? Now I think we do the same thing for the other table. What's the chances at risk, positive, what's the chances you have HIV? Okay, is that correct? Part C. In the at risk, test positive for the disease. So how many test positive for the disease? That's 700. As a doctor using this table, how would you describe the patient's chances of actually having the disease? Oh, so I got this mixed up. So there's 700 that test positive. What would you tell the patient who tests positive? Well, there's a 2/3, roughly 2/3 is 67%. So I would say there's a 2/3 chance you do have HIV, and there's a 1/3 chance, 1 in 3, or a 33% chance, or 32% chance you don't. That's what I would tell the patient. It's not as, if testing positive isn't a for sure thing. There's a good chance you don't have it. Okay? Now on this one, they want you to do the same thing. So general population that have HIV, that's 60 people, and 57% 57 test positive, which was, as we worked out from the very beginning, that was the 95%. We knew that, that's how we got the 57. 95% of the 60 was infected, tested correctly. But what percent test positive that really don't have AIDS or do have AIDS? Well, the ones that do have AIDS, of the ones testing positive, of the 1,014, how many really do have AIDS? All of these tested positive. They're testing positive. How many really do have AIDS? Well, that's 57, or HIV. That is what percent? 57 divided by 1014 is about 6%. So, general population, you went and got a test. Of the 1,000 people that took the test, 57 were the only ones that had A. Only 6%. So, if you test positive in general, and you're from the general population, there is only a 6% chance you have it. There's still a 94% you don't. And that's because there's such a huge imbalance between these two. A whole lot of people, of which 5% are going to be tested incorrectly. So that becomes a lot of people that test positive and don't have the HIV virus. Only 57 will. And that many won't of all that test positive. Okay? And that's what they wanted you to explain in this last part. I wrote the wrong thing here. So it's kind of like this one. So there's a 94% chance you don't. That's what this last part E was supposed to say. Okay? That is it for 3E.